Hi, I'm Robin Higgins, and this is Probability and Statistics in Chemistry. All right, so it's basically just good to have an understanding of how probability and statistics really affects all sorts of science. And so let's go over just one example. So let's say that you are looking at raccoons and you're counting their stripes. Okay, so what you're going to do is you're trying to find out how many stripes do most raccoons have on their tails. And let's say the options are 3, 4, 5, 6, and 7. So your experiment is basically going to be going out, looking at some cute raccoons, counting how many stripes they each have. So let's say you go out one night and you see a family, and it's a family of 5, and they have 2 raccoons with 4, and they have 1 with 6, and 2 with 7. And let's say you end your study there, and you say, all right, I found out at the end of my report, it's that some raccoons have 4, some have 6, some have 7, but none have 3 or 5, and 4 and 7 are tied. Well, you really haven't proven that yet because of statistics and probability. The probability of you knowing the exact breakdown of raccoon stripes after only 5 samples is very low. So this is something that scientists take a long time to get used to, is that even if you have some data, you don't really know it unless you have a proper study. So for instance, there's a lot of urban legends or folklore about how to predict the gender of a baby. So you might have a grandma who says, oh, if you have an upset stomach on your 4th month of being pregnant, it means it's going to be a boy. And then you have that person who gets pregnant and they have an upset stomach on the 4th month and it's a boy, and then people will be like, it works, you can totally tell the gender of a baby that way. But that's only one study, and considering there's only 2 possible genders, that's just really not very good data. So let's take a look back at this raccoon study, and let's pretend that we did a really good job on it. We went out for a bunch of months and saw lots of raccoons over different states, and they're all cute and feisty. And then at the end of it, we found there's actually 305 that had 3, and let's say 2,000 that had 4, and just 10 that had 5 stripes, and maybe 10,000 that had 6. And then only 200 that had 7 stripes. So these are more accurate numbers because we have a larger sample size. So now you can really tell that most raccoons have 6 stripes, and that some have 4, and that really the fewest number is 5. So if we had stopped here, we wouldn't have known really any of this correct data. And exactly how many samples you need to have your own study work out is dependent on what you're doing, and there's lots of math to back up how well you know what you think you know. But in general, it's just important to have this knowledge in the back of your mind, that only a few samples isn't really good enough for science. I'm Robin Higgins, and this is Statistics and Probability in Chemistry.